네, 여러분 반갑습니다. 저는 한국 냉동공조 국제심사의 문현주라고 합니다.
Nice to meet you, everyone. I'm Hyunju Moon. I'm a Korean expert for the refrigeration and air conditioning skill.
네, 저희가 지난 1회차 라이브 방송은 잘 마무리가 됐고 오늘 그 2회차 라이브 방송이 시작될 예정입니다.
We had our first live streaming session last week, and then I think it was going very well. And then today it is the second session for the live streaming.
오늘 저희가 라이브 방송을 하게 될 그 내용을 간략하게 좀 설명을 드리고 진행하도록 하겠습니다.
I'm going to introduce today's main contents for the live streaming briefly. So we are going to handle the video clip from number 4 through number 6. And then for the video clip number 4, we are going to talking about the pressure test and the evacuation test by continuing the content which had in the last session. And next, we are going to talk about charging refrigerant into refrigeration module and the electrical continuity and insulation test. And then lastly, we are also going to deal with the how to set pressure switch and temperature controller.
오늘 비디오를 오늘 보면서 이제 4차 시 4, 5, 6차 시 비디오를 보면서 설명을 차차 드리겠습니다.
I'm going to give some explanation about today's lecture by watching the video clip from number 4 through number 6 together. Now let's have a watch the video clip about the pressure test and evacuation test.
소리 나가나요?
Examine the pressure of refrigerant piping with nitrogen pressurization. Connect the yellow service hose of the manifold gauge to the nitrogen gas cylinder. Before the nitrogen pressurization, open all valves in the refrigeration unit so that there are no obstruction.
네, 지금 작업자가 보면은 몽키 스패너로 이 부분을 지금 이 부분을 조절하고 있는데 다시 한번 조금만 더 보겠습니다.
Actually, the workers is adjusting the part with the spanner a little bit. So let's watch the little bit more.
지금 작업자가 조절하고 있는 요 서비스 발브 요 하부를 보면은
Please have a look at the bottom part of the service valve, what the worker is adjusting.
요 윗부분이 그 스템이라고 이제 얘기를 하고 있고요. 발브 스템.
The upper part for the service valve generally called as stem.
네, 지금 작업자가 만졌던 이 부분은 스템 실 부분입니다. 스템 실.
And the point where the worker is touching on the video is a stem cell.
모든 작업자들은 이 발브를 손대기 전에 이 부분을 먼저 느슨하게 풀어주고 시계 반대 방향으로 한 반 바퀴에서 한 바퀴 정도.
So all competitors should adjust the service valve part by making the part loose by adjusting it unclockwise, half turn or the one turn.
그다음에 스팀 발브를 이제 열어서 원하는 오픈, 풀 오픈 또 풀 크로스 또 아니면 중간 정도의 발브 조정을 하시면 되겠습니다.
So by opening the stem valve, you can adjust this part such as the full or the cross open.
풀 오픈이 되게 되면은 이 발브 위치는 탑 위치에 될 것이고요.
If you adjust the valve part as the pull open, the valve switch is going to be open.
이때 모든 이쪽 지금 보이는 요 포트는 잠기게 됩니다.
The other part of what you're watching on the mouse cursor now is going to be closed.
유체는 지금 이렇게 통해서 이렇게 흐르게 되겠고요.
The flow inside of the pipe is moving according to the mouse cursor's movement.
이쪽 방향으로 역방향으로 흐를 수도 있겠죠.
Maybe it can flow into the reverse way.
지금 제가 이게 그리는 게 송출이 되고 있나요? 네. 다음번에는 이제 그래서 우리가 이제 작업을 하기 전에 여기를 우리가 이제 손을 대야 되기 때문에 요 발브를 풀 오픈해야 됩니다. 요 스템을 풀 오픈, 시계 반대 방향으로 돌려서 풀 오픈 시켜주시면 되겠습니다.
To continue the task, the competitor should adjust the red point part by making it full open by turning this part into the unclockwise.
그렇지 않을 경우에 장치 내에 있는 냉매가 밖으로 분출되거나 아니면은 밖에 있는 진공 상태일 경우는 밖에 있는 공기가 안으로 빨려 들어갈 수도 있기 때문에 매우 중요한 사항입니다.
Otherwise, the refrigerant can be leaked out from the pipe or the air in the atmosphere can insert it into the inside of the pipe. So it is a very important task and the thing the competitor need to do.
반대로 요 스템을 끝까지 완전히 잠그면은 밑으로 내렸을 경우 포지션을 완전 크로스했을 경우
unlike the previous task, if the competitor closed the stem part fully,
그러면은 이제 요쪽 부분, 요 부분만 크로스가 됩니다. 제일 하단부 요쪽 요쪽 배관 쪽으로 가는 부분만.
the bottom part, what I just mark on the screen,
문자가 돼 있어.
is closed.
그래서 유체는 이쪽에서 열로 흐를 수도 있고요.
The flows in the pipe can be the way what I just draw,
반대 방향으로도 물론 흐를 수 있습니다. 압이 높은 곳에서 낮은 곳으로.
or it can flow into the reverse way from the higher place to the lower place.
만약 요 스템 발브가 최고점 탑 또는 최하점에 있지 않고 요 중간 사이에 있을 경우
If the stem valve is not located on the top or bottom, so if the stem valve is located in between the top and bottom,
지금 이쪽 니플 그다음에 요 배관 두 개, 요 모든 게 다 열리게 됩니다. 즉 이쪽 부분에서 열로 순환도 되고 또 요 부분에서 이쪽으로 순환도 되고 여기서 또 이쪽으로 순환도 되고 그러니까 세 개가 다 연결이 돼서 다 통해져 있게 되는 상태가 됩니다.
in this case, the nipple and the two pipes is all open. So all three parts is connected together. So the flow is connected all.
다시 한번 설명하면 풀 오픈 상태에서는 모든 밸브가 다 모든 부위가 요 부분이 잠겨 있고 요쪽 파트하고 이쪽 파트가 서로 연결이 되는 상태입니다.
So to repeat the explanation one more time, if the competitor perform the full open, the first part is closed and then the other two part is connected.
크로스가 됐을 때는 풀 크로스가 됐을 때는 뒷선 이 두 개가 서로 열리게 되고요. 요건 잠기게 됩니다.
So if the competitor do the full cross task, the first two parts are connected and then the last part is closed.
중간 요 스템 발브가 중간 탑하고 제일 윗점하고 제일 아래점 중간 위치에 있을 때 요 세 개가 모두가 서로 열리게 됩니다.
And then lastly, if the stem valve is located in between the top and bottom, all three parts are connected together.
마우스는 보이나요? 마우스는 보이나요? 지금 요 화살표 보이는 요 아까 설명드린 스템실은 그 스템과 냉매가 흐르는 요 발브 쪽에 실링을 하는 역할을 하기 때문에 아까 반 정도 풀어줬고 항상 이쪽은 반드시 반 내지 한 바퀴 풀렸다가 반드시 잠궈야 됩니다.
So in case of the stem cell, what I just pointed, always should be or turn, half turn or the one turn, and then need to be closed for sealing.
다시 계속 보겠습니다.
Let's watch the more
Open
video.
all the solenoid valves that only open through electricity by using the solenoid valve opening magnet.
음이 안 나오는데요.
You cannot use the general magnet at this time. The blue hose of the manifold gauge should be connected to the low pressure port, and the red hose should be connected to the high pressure port. What is manifold gauge? The solenoid valve. Open all the solenoid valves that only open through electricity by using the solenoid valve opening magnet. You cannot use the general magnet at this time. The blue hose of the manifold gauge should be connected to the low pressure port, and the red hose should be connected to the high pressure port. What is manifold gauge? The manifold gauge consists of two gauges, two passive valves, and three separated connecting hoses.
매니폴드 게이지 부착하는 거는 청색은 로우 프레셔 사이드, 그다음에 적색은 하이 프레셔 사이드에 우리가 체결하게 되어 있는데 로우 프레셔 측은 로우 프레셔 서비스 발브가 있으면 서비스 발브에 서비스 발브가 배관 라인이 없을 때는 이제 압축기의 대부분이 서비스 발브가 있는데 압축기 측, 흡입 측 서비스 발브에 설치하면 되겠습니다.
So this is about how to connect the manifold gauge to the system. So in case of the blue hose, it should be connected to the low pressure pot. So if there is a service valve, you can connect this hose to the low pressure part on the service valve. But if there is no service valve, you can connect this blue hose to the compressor. And then in case of the red hose, you can connect this hose to the high pressure part.
저희까지 다 한 거죠.
What is manifold gauge? The manifold gauge consists of two gauges, two passive valves, and three separated connecting hoses. It is used in many different tasks for a refrigeration system, including evacuation test, refrigerant. Refrigerant recovery, all sorts of pressure tests, as well as a nitrogen pressure test. When using a manifold gauge, there should be no filth around the hoses and the connecting parts. There should be no moisture and air inside the hoses as well. Control the pressure of the nitrogen gauge. The nitrogen gas cylinder is high pressured, so you must control the pressure through the gauge, which is equipped with a decompression device. Before the pressure test, check if there is any signs of leakage on the connecting parts of the manifold gauge and nitrogen gauge, and any other area that is prone to leakage with a soapy water. When conducting a leakage test, you should place a dry cloth underneath to prevent soapy water from dripping onto the floor. Open high and low pressure valves so that the nitrogen gas can be pressurized into the refrigeration unit. When opening and closing the valves of the manifold gauge, turn them slowly to make sure strong pressure is not applied abruptly on the gauge. The nitrogen pressure should be based on the low pressure gauge of the manifold gauge. The nitrogen must be pressurized up to the suggested standard in the competition. When pressurizing the nitrogen gas, the pressurization should be conducted slowly for safety. What is a nitrogen pressure test? The nitrogen
예, 지금 그 압력 게이지에 지금 보면서 압력을 이제 가압을 하고 있습니다. 작업자가.
The worker on the video clip is giving or applying the pressure to the system by checking the gauge on the manifold.
예, 원칙적으로는 저압을 보고 하는 게 좋습니다. 왜 그러냐면 저압은 눈금이 세밀하기 때문에 그 압력의 변화를 쉽게 우리가 읽을 수 있고, 고압은 눈금의 변화를 쉽게 읽을 수가 없습니다. 왜냐하면 그 범위가 크기 때문에 세밀하지 않아서요.
So actually, we normally recommend to check the pressure by checking the low pressure side, because low pressure side gauge has the very minor range, so it is easy to check the change of the pressure. But in case of the high pressure part on the manifold gauge, it has a big range between the indications comparing to the low pressure part.
그래서 이제 로우 프레셔 쪽을 하는 게 좋긴 하는데, 저희가 테스트하고자 하는 압력이 로우 프레셔 게이지 사용 압력보다 높을 경우, 예를 든다면은 매니폴드 게이지의 최대로 볼 수 우리가 확인할 수 있는 사용 압력이 10바인데 우리가 이제 가압해야 되는 압력은 15바. 그러니까 게이지에 표시된 압력보다 우리가 더 높은 압력을 걸 때는 게이지가 측정을 할 수도 없을 뿐만 아니라 게이지의 고장의 원인이 되기 때문에 그때는 이제 하이 프레셔 쪽을 이제 사용하게 됩니다.
We normally recommend to use the low pressure part to check the pressure, but there is some case we recommended to use the high pressure part on the manifold gauge. For example, if the maximum service pressure is 10 bar, but the maximum pressure for the pressure test is suggested as 15 bars, it is not available to measure the pressure with the low pressure part, and then sometimes it causes some malfunction of the manifold gauge. So you need to use the high pressure part in this case.
만약에 저희가 이제 매니폴드 게이지 말고 이제 장비에 고저압 게이지가 있으면은 그거를 기준으로 할 수도 있습니다.
For example, in case that we have a high and low pressure part on the equipment itself instead of the manifold gauge, we also can choose to use the high pressure and low pressure gauge on the equipment.
뭐를 이제 이용할지는 아마 대회에서 심사위원들이 결정해서 제시를 할 겁니다.
In the competition, these things is going to be decided and circulated to the competitor.
자, 다음 그 압력 방치 시험은 저희가 15분 동안 사실은 아무런 변화도 없어야 됩니다.
The next procedure is about the pressure test part for leaving the cycles for 15 minutes. So for 15 minutes, there should be no change in the pressure.
근데 지난 카잔 대회에서는 이제 우리가 1도씨의 압력 강화를 인정해 주었습니다.
In the last competition in Kazan, In our skill, we allow the pressure as much as the pressure which is the same as the 1 Celsius degree.
저희 직종 그 작업 스탠다드에 보면은 아무런 이제 변화가 없어야 된다고 적시되어 있습니다.
According to our skills standard, it mentioned that there should be no change in the pressure at all.
이 모든 것도 이제 과제에 이제 어떻게 나와 있는지 여러분들이 과제를 잘 살피고 과제에 의해서 여러분들이 작업을 진행하면 되겠습니다.
All of these things should be checked through the test project and then the instruction on the test project.
선수에게는 가압 시험을 할 수 있는 2번의 기회가 주어집니다.
In case of the pressure test, all the competitor is going to have 2 times of a pressure test.
1차에서 합격을 하면은 풀마크를 받을 것이고요.
If the competitor passed the first trial of a pressure test, they are going to get the full mark for this test.
1차를 불합격 통과하지 못하고 2차에서 합격하면은 1차에서는 점수를 잃을 겁니다.
In case that the competitor failed the first trial but passed the second trial, they are going to lose the mark for the first pressure test.
모두 1, 2차를 모두 통과하지 못했을 경우는 2개의 점수를 다 잃을 것입니다.
In case that the competitor failed to pass the 2 times of pressure test all, then they are going to lose all the mark for the pressure test.
모든 질소 가압 및 방치 시험은 선수가 독단적으로 해서는 안 되고 반드시 심사위원이 입회한 상태에서 작업을 해야 됩니다.
So regarding to the pressure test, all the competitors should perform this pressure test and their relevant task under the expert supervision.
예를 들어서 심사위원 입회하지 않고 본인이 자체적으로 누설 부위를 검사한다는 것은 정당한 방법이 아닙니다.
For example, if the competitor tried to check the leaking part on the system by himself or herself without any expert supervision, it is not a fair procedure.
그래서 점수를 잘못하면 잃을 수도 있고
So in this case, the competitor also can lose all the mark for the pressure test.
또 다른 또 어떤 문제가 생길 수 있으니까 반드시 질소를 넣기 전에는 심사위원을 먼저 불러서 심사위원 입회하에 작업을 하는 게 좋겠습니다.
Or to prevent the other accident or other problems, the competitor should perform this task under the expert supervision. This is mandatory.
그 1, 2차를 모두 실패한 선수는 이제 본인이 자체적으로 새는 부위를 찾아야 이제 진공 작업에 들어갈 수가 있겠습니다.
Even if the competitor failed to pass the 2 times of the pressure test, they need to find out the leaking part and then they can move to the next step, the evacuation test.
Pressure test refers to a test to check if there's any leakage while the pressure vessels such as compressor and a condenser is connected to the valve after pipe work is finished. After pressurizing the nitrogen gas up to the standardized point, you should inspect every connecting parts with soap water. There also should be no drop in pressure on the pressure gauge for a certain period of time. Nitrogen gas is used for a pressure test. The reason for using the nitrogen gas is because nitrogen gas is a chemically stable gas and has no danger of explosion even when it is mixed with other substances, and it can be pressurized at high pressure and the pressure is less likely to change due to the ambient temperature. The reason for not using the air is because the air contains some moisture itself. If air gets pressured, the moisture in the air starts to condense, which can cause a failure during operation. When the nitrogen pressure inside the device reaches the standard point, close the valves of the nitrogen cylinder and the manifold gauge. While keeping the pressure for the leakage test, check for leakage in all possible areas such as the brazed parts and nut-fitting parts with soapy water. There should be no leakage in all of the inspected area. After the nitrogen pressure test is finished, leave the refrigeration unit for a certain amount of time and check if there is any pressure drops. You can move on to the next step after no leakage is verified. After leaving the refrigeration unit for a certain period of time, discharge the nitrogen gas in the equipment towards the service hose by opening the high and low pressure valves of the manifold gauge. When discharging the nitrogen gas, you should not discharge it into the air, especially to the upper side of the liquid receiver. Just as pressurizing, the gas must be discharged slowly in extremely small amounts to prevent safety accidents. Check whether the nitrogen is completely discharged through the scales on the manifold gauge. Check if all needles of the gauge indicate 0. Disconnect the nitrogen cylinder from the system and seal all connecting parts that are open to the outside, such as valves and pipe ends with service caps. After completing the pressure test, have the completion verified.
예, 지금까지는 이제 프레셔 테스트에 대해서 설명을 드렸고요. 지금부터는 이제 바큐음에 대해서 설명을 드리겠습니다. 비디오 보시면서 중간중간 제가 보충 설명을 드리겠습니다.
It was about the pressure test so far, and then now we are going to move to the next step, the evacuation test. So I'm going to give the brief explanation regarding to the evacuation test by watching the video clip together.
Check the required tools for the evacuation test. The required tools are a vacuum pump, a vacuum gauge, a manifold gauge, and etc. For the evacuation test, open all valves of the equipment. What is an evacuation test? The evacuation test is to remove the non-condensing gas or moisture remaining inside the refrigerator and inspect the device for leakage before charging the refrigerant after the leakage test. Connect the vacuum gauge to the vacuum pump and turn the power on the vacuum pump, then check whether the value of the vacuum gauge decreases below 1,000 microns. The vacuum pump serves to remove any remaining moisture, air, and non-condensable gas inside the refrigeration system. When using a vacuum pump, you should place it on an even surface. Before using the pump, check whether the oil is at the normal oil level through the gradation of oil level gauge. The ability of the vacuum pump is judged by its discharging capacity. The bigger capacity the vacuum pump has, more time can be saved for the evacuation task. It is important to choose the appropriate vacuum pump with the corresponding capacity depending on the task. If you use a vacuum pump with small capacity compared to the task, the spent time gets longer and the lifespan of vacuum pump can be shortened. What is vacuum gauge? It indicates the evacuation level of the system being evacuated. For now, check whether the vacuum gauge indicates the desired vacuum level based on the standard point designated in the task. After the gauge efficiency test, connect the vacuum gauge to the refrigeration unit. The vacuum gauge should be installed as far away from the vacuum pump as possible. However, where the vacuum gauge should be installed might vary depending on tasks of competition. During evacuating, you cannot use the high vacuum hose that is installed to the vacuum pump. Instead, connect the service hose of the manifold gauge to the suction part of the vacuum pump. Open low and high pressure valves of the manifold gauge. Open all sorts of valves inside the refrigeration system. Turn on the vacuum pump to run it. And open the high and low pressure valves of the manifold gauge. Start the evacuation process and aim to be below 1,000 microns before the time given for the task is over. If the
지금 이제 바큐음을 이제 시작할 때 예전에는 1시간 이내에 1000 마이크론즈 이하까지 다운을 시켜야 되는데 지금은 최근에는 이제 시간 제한 없이 작업 시간 내에만 1000 마이크론즈 이하만 이제 진공을 잡으면 됩니다.
So the video clip just to show about starting the evacuation test. Actually, existing rule for the previous competition, it just instructed that the competitor should make the vacuum under the 1,000 microns within 1 hour. But recently, we just eliminate the hours limitation rules, and then we just make the competitors reduce the vacuum under the 1,000 microns.
선수는 최대한 1000 마이크론즈 이하로 딥 바큐음을 하는 게 유리합니다. 예를 들어서 900 마이크론즈보다는 500, 400, 300 더 낮은 수치의 딥 바큐음이 중요하겠습니다.
So all competitors should try to do their best to make the deep vacuum. For example, it would be better the level of vacuum is small than smaller and smaller. For example, 500 would be better than the 900 microns, and then 400, 300 would be the best.
evacuation level does not be below 1,000 microns, you should keep going until it reaches the desired state. Evacuating the system is necessary for charging refrigerant and normal operation of the refrigeration system. If the gauge If the vacuum pump Suggested in the pressure prevent non-pressure.
I think there is some technical issues regarding to the Zoom and the YouTube live streaming. I'm really sorry for your inconvenience. So regarding to the evacuations by leaving the systems for 10 minutes, there should be not that many change in the vacuum level. So for example, if the competitor makes the vacuum and then there should be no more than 5 microns or 5 microns or more than 5 microns rise in the vacuum level. But it's depending on the competition. So in the other competitions, we also instructed that the competitor just make the vacuum state just under the 1000 microns. In the last competition in Kazan, we on the test projects, it mentioned that all the competitors should make the vacuum level under the 1000 microns, and then after leaving it for 10 minutes, it shouldn't be rise as much as 500 microns or more than 500 microns. So as you can see from this video clip and explanations, there is some description in the standard about this, but depending on the competition, the instruction regarding to this can be vary.
Be as low as around charged refrigerant should be recorded and then totaled up at gas from being mixed. Milligrams per centimeter.
I'm really sorry for being making any inconvenience because of the technical issue. I'm really sorry for that.
If the evacuation check again the key points of the task we've worked on in this training. Please check what you are going to perform on this task.
Now I'm going to give you the lecturing about charging the refrigerant. And then because of some technical issues, so it's a little bit embarrassed at the moment, but we're trying to do our best by focusing on our next content over time.
This is charging refrigerant. Make sure to wear a suitable safety gear according to the working refrigerant. This is charging refrigerant. Make
So when the competitor tries to start to use the manifold gauge, they need to make sure to adjust the manifold gauge indicating needle to the 0 point. So by adjusting the straight line little bit by the screw, by screwing it, they need to make sure to adjust and point the manifold gauge on the 0 point. When measuring the weight of the refrigerant cylinder, the competitor should make sure to measure only the refrigerant cylinder itself. So it means that they should measure the refrigerant cylinder while disconnecting all the manifold gauge.
Make sure to wear a suitable safety gear according to the working condition. Make sure to wear safety goggles and gloves to prevent burns in case of contacting to their eyes or skin. Open all valves of the modules that have been evacuated. Make sure to charge the refrigeration system with the refrigerant after completing the evacuation process. It is important to charge the refrigeration system with the optimal amount of refrigerant that the This and gloves to prevent burns in case of contacting to their. This is charging refrigerant. Make sure to wear a suitable safety according to the working condition. Make sure to wear safety goggles and gloves to prevent burns in case of contacting to their eyes or skin. Open all valves of the modules that have been evacuated. Make sure to charge the refrigeration system with the refrigerant after completing the evacuation process. It is important to charge the refrigeration system with the optimal amount of refrigerant that the system requires. Before charging the refrigerant, check whether the refrigerant scale is zeroed and place the refrigerant cylinder onto the scale to measure its weight. The refrigerant scale is measuring the amount of refrigerant injected into the refrigeration system. After recording its weight, check whether the manifold gauge is adjusted to zero, and connect the manifold gauge to the refrigerant cylinder and the refrigeration system. Connect the yellow-colored service hose of the manifold gauge to the refrigerant cylinder. Connect the blue-colored low-pressure hose of the manifold gauge to the high-pressure part of the refrigeration system. Connect the red-colored high-pressure hose to the low-pressure part of the refrigeration system. Before charging the refrigerant, part of the refrigeration system.
So actually there was some little minor mistake and an error on the subtitle and the narration. So we are going to correct this part a little bit by watching it together. The yellow hose need to be connected to the refrigerant cylinder. The red hose need to be connected to the liquid line on the high pressure part or the liquid receiver. Lastly, the blue hose need to be connected to the low pressure part of the equipment or the service valve on the suction line.
Manifold gauge to the refrigerant cylinder. Connect the blue-colored low-pressure hose.
Actually, the worker on the video clip is working in a right procedure and order, and then the method. But the narration just mentioned a little bit incorrect information, so we just correct this part for all of you guys.
Manifold gauge to the high-pressure part of the refrigeration system. Connect the red-colored high-pressure hose to the low-pressure part of the refrigeration system. Before charging the refrigerant, make sure to purge some non-condensable gas in the hose. Turn the refrigerant cylinder upside down and then slightly open the valve on the refrigerant hose to purge it. Conduct the purge work with the minimum amount of refrigerant at this time. Reason for turning the refrigerant cylinder upside down is to charge the refrigeration system with the refrigerant as liquid type. The mixed refrigerant, such as pure HFC or R400, has the different mixing ratio depending on its type, liquid type or gas type. Therefore, make sure to turn the cylinder upside down to charge the refrigeration system with the accurate amount of refrigerant as liquid type. The refrigerant used by the worker now is
In the competition, we normally use the two types of refrigerant, such as the mixed refrigerant or the single refrigerant. The refrigerant what the workers is using on the video clip is R4048. This is the mixed refrigerant. In the London competition, this type of refrigerant R4048 was used. After that competition, in our skills competition, we normally use the refrigerant 1348. So in case of the air conditioning system, we generally use the refrigerant R4108 or R4108. Actually, in Korean National League and then Korean Domestic Institute, we also generally use the refrigerant R4048 type. Because of the global warming potential, so aka GWP, we are trying to stop using this type of refrigerant, and then we are trying to do our best to use the different type of refrigerant from next year.
the mixed refrigerant R404A. Refrigerant cylinders are color-coded by type. This is to prevent mixing and misuse by distinguishing refrigerants during the process of handling refrigerants. After finishing the purge, inspect whether there is any leakage on the connections of the manifold gauge and hoses from the refrigerant cylinder to the refrigeration system with a gas detector. With a gas detector, you can conveniently detect even the small amount of leakage. If the gas detector is touched on a leaking part, it shows up the light or rings an alarm. From right after
So the worker on the video clip is charging the refrigerant block now. So regarding to charging the refrigerant, the leak test should be done by the competitor. So generally, in case of that, the competitor apply the nitrogen to the system, they need to use the soap water. And then in case that the competitor use the refrigerant to the system, they need to use the electric gas or leak detector. So in case that the competitor use the electric leak tester for checking the leakage, they need to do this test for 3 times in total. So first, when the manifold gauge and the refrigerant cylinder and the equipment is connected and all the connection is completed, they need The second time for the leak test is when the compressor is charging the refrigerant. Lastly, the competitor need to do the leak test after finishing the refrigerant charging. So they need to make sure to put all the caps on the cylinder and the equipment that they need to check the leak test.
After the expansion valve to the suction part of the compressor, insulate pipes and components using heat insulation. For the heat insulating materials, you may use the rubber foam insulation or the Artelon insulation suggested in the materials list. In case of using the rubber foam insulation, glue the split part with the adhesive glue. In case of using the Artelon insulation, finish it using the tape. When wrapping the heat insulating materials with the tape, make sure not to apply too strong force because it can cause a deformation of the heat insulating materials. Separate the insulated gas line with the liquid line without wrapping them together. Check the charged amount of refrigerant through the sight glass installed on the refrigeration system. If no bubble is seen on the sight glass, if the bubble is formed inside the sight glass but does not move, or if the bubble is formed at the entrance of the sight glass but seen at rare intervals, this indicates the refrigerant is sufficiently charged. If the flow of the refrigerant is observed, or if the bubble moves constantly, this indicates the refrigerant is insufficient. So, make sure to keep charging it. When dealing with the refrigerant, make sure to fully understand how to handle it and follow the suitable charging method. These are general precautions on dealing with the refrigerant. The refrigerant should be kept away from the flame or the electric heater. Generally, the temperature of the refrigerant cylinder should not exceed over 52 degrees Celsius. Do not pressurize the refrigeration system or the refrigerant cylinder which contains the refrigerant with air to inspect the refrigerant leakage. Use the cylinder that is qualified by the regulation and do not damage the valve of the safety device for releasing the pressure. Work at a well-ventilated place when dealing with the refrigerant. Check whether the designated amount of refrigerant is charged through high and low pressure gauge and close the main valve of the refrigerant cylinder. Close the service valve of the liquid receiver and purge the remaining refrigerant in the manifold gauge through the compressor's Schroeder valve. Disconnect the refrigerant cylinder and the manifold gauge from the refrigeration system and record the charged amount shown on the refrigerant scale.
The worker in the video is reclaiming the refrigerant to the suction line from the refrigerant hose. But this procedure and then this task is going to be repeated on the other procedure. So we are going to give the explanation about this task in our next session. So we are going to skip this part for now.
After the charging is completed, the refrigerant cylinder should be capped. Make sure to conduct a leakage test with a gas detector. Put the refrigerant cylinder down and organize the refrigerant scale.
From now, this video is like just showing about the electrical continuity test and the insulation test.
This is an electrical continuity and insulation test. Check the 0 point of the multimeter before the inspection. Turn on the earth leakage circuit breaker so that all control lines can be inspected through the power plug. While referring to the electrical drawing, test continuity of the L and N phase and grounding wire from the plug to the control circuit. Continuity inspection of the ice rink and heat recovery coils is also required during the grounding continuity inspection. Inspect L and N phase for short circuits on the power plug. Inspect insulation of L phase and grounding on the power plug. Inspect insulation of N phase and grounding on the power plug. If there is no particular instruction in the test project, set the menu of the multimeter to bell tester. The warning sound of bell tester will turn off when it is greater than during the continuity test. If the warning sound goes off, it means that the wire is disconnected.
So now I'm going to give you an explanation about the electrical continuity test by watching the diagram together. So the first one is about the L line, the live line. So you can see and then follow my mouse cursor to check the live line. So actually the live line means that the line which is authorized the voltage or power. So in case of Korea, we use the 220 voltage. So it's going to be 220 voltage. But in the other country, it can be 150 or 100 voltage. Second one is the N line, the neutral line. This line must be the 0 voltage, and what you just saw my mouse cursor, the flow, this is the L line, neutral line. So such as the number 38 and the number 14. PE line means the OS line. So generally, OS line is on the pressure switch, like a high pressure part, and then the fan controller and the solenoid valve. So the continuity test is to check all the connection between the lines and the inside of the line, in the line.
When wiring, make sure that all electric wires, including grounding wires, are firmly connected without missing a single wire according to the electric circuit. Inspection of the circuit before energization is very important, as the normal operation is required without any fuse blowing and circuit breaker tripping during the initial power-up. Circuit inspection can usually find disconnection of fuses and components, open and short circuits of coils or wires, and whether there is earth leakage. If you contact the red-colored lead-in wire pin and the black-colored lead-in wire pin at both sides of the fuse, the resistance should be 0 or point to a constant number. But if infinity symbol is shown, that means it's disconnected. If the control circuit inspection is finished, conduct the line-to-line test and the earth insulation inspection at the load circuit. Now, there are two load circuits. They are motors of the compressor and the condenser. Conduct line-to-line insulation and earth insulation tests of the two motor coils. Use a mega ohm meter instead of a digital multimeter. It is an earth insulation inspection of a load circuit that inspects the grounding bar of the control box, L and N phases, on the MC load side. If the resistance value is over a certain standard point, it is judged to be electrically insulated. Before energizing the system, make sure to check whether the earth insulation resistance value is over 1 mega ohm. It is a line-to-line insulation inspection of load circuits. It measures the values of L and N phases on the MC load side. If all tests are completed, put away the multimeter.
Regarding to the insulation test, the insulation test mainly divided into the control circuit part and the power circuit part. In case of the control circuit, the competitor need to use the multi-tester for checking the insulation test. In case of the power circuit, the competitor need to use the mega tester for the insulation test. In the difference between the multi-tester and the mega tester, in case of the multi-tester, it is only check and test the resistance. In case of the mega tester, it also tests the resistance value, but in case there is the actual service voltage already authorized on the motor. So, for example, if the competitor mistakenly used the mega tester for the control circuit, actually the mega tester generally use the high voltage such as 250, 500, or 1000 voltage. The mega tester, what the worker is using on the video, is the one which uses the 500 voltage. So in this case, if the competitor used the mega tester to the control circuit by applying the 500 voltage to it, actually in this case, there can be some damage on the electrical component or equipment such as a temperature controller. So actually, in the real workplace or in the competition, because of this minor mistake, there can be occur some big accident or happens. And then one more thing is that this kind of insulation test should be performed by competitor when the refrigerant is already completely charged to the system. This is because if there is any air inside of the system, or if the system is under the vacuum state, it is hard to test and check the right insulation. So actually, because of a lot of technical issues, what happened during today's lecturing sessions, there was too many delay in the lecturing and then the live streaming session. So we are going to give you the explanation or the lecturing about the video clip number 6 regarding to the pressure, the setting of the pressure switch and then temperature controller. So I'm so sorry for your inconvenience, which is caused by the technical issue today. So from next time, we are going to get prepared for all the things a little bit more and thoroughly. Actually, I prepared for this second session of the lecture for 2 weeks a lot by utilizing various material, all the technique to show you guys a lot of things, but it wasn't going very well today's session, so it's a little bit embarrassing and I feel sorry about that. Despite for the unstable broadcasting situation, thank you for joining and then watching this video clip to the end. So thank you for today, and then let's see you in our next session, third sessions.
Thank you all, and we can understand that